Hello friends, today's question. Consider a thin square plate floating on a viscous liquid in a larger tank. The height h of the liquid in the tank is much less than the width of the tank. The floating plate is pulled horizontally with a constant velocity u0. Which of the following statement is or are true? So these are four statements. First two statements are based on the resistive force of the liquid, and C and D are based on the tangential stress on the plate. So we are going to use two equations. One is that is based on resistive force, and the one is based on the tangential shear. So we can say that when the plate moves horizontally over a thin layer of viscous liquid, the resistive force F due to viscosity of the liquid it is given as F is equal to nu a u0 divided by h, where nu is the viscosity of the liquid. Yeah, it's not mentioned. Viscosity of liquid. A is area of cross section. Area of the plate in contact with the liquid. Area of plate in contact with liquid. u0, which is given in the question itself, u0 is the constant velocity of the plate. Constant velocity of the plate, and h is the height of the liquid layer. Height of liquid layer. So let us do first A and B part based on this equation. Let us check option A, which states that resistive force on the liquid on the plate is inversely proportional to h. So let us call this equation number 1. So you can say that from equation 1, force is directly inversely proportional to h. So where F is applied force and h is the height, so it is given as F is inversely proportional to h. So this statement is true. You can see true. Let us check option B. And option B states that resistive force of the liquid on the plate is independent of area of plate. But as per equation 1, we can see that force is directly proportional to A. So from equation 1, force is directly proportional to A. You can say force is directly proportional to A. So So it means that this option is false. So therefore, option B is false. Now let's for C and D, we need another equation. So for that, you can write that the tangential or shear stress or shear stress denoted as tau on the floor of the tank due to viscous liquid and it is given as tau is equal to nu naught upon h. So this parameter description is same. Nu is the viscosity, nu naught is the velocity, and h is the height. So let us check for option C. And option C states that the shear stress on the floor of the tank increases with nu naught. From here, let us call this equation number 2. You can see that shear stress is directly proportional to nu naught. Okay. You can say from equation 2, tau is directly proportional to nu naught. So which basically means that as u naught increases, tau also increases, and which is said in the question itself, in the option itself. So C is true. And the last option states that the tangential or shear stress on the plate varies linearly with the viscosity and nu of the liquid. From equation 2, shear stress is directly proportional to nu. It means as nu is going to increase linearly, similarly tau is also going to increase. So this option C is true. And now we come to option D. So from equation 2, tau is directly proportional to nu. So we can say there is linear or directly proportional relation between tau and nu. So it means that this D option is also true. This option is also true. So finally, we can say that our options A, C and D, these are true, whereas our B option is false. So this completes the question. Thank you.